Very good day. My name is Surendren Ganeshan, and I'm from a Bachelor's in Computer Science, majoring in Cybersecurity. And this is my presentation for my final year project, FYP2. And this project, I would like to propose a research project, which is a machine learning DDoS detection system in software defined networking. So basically, this whole research project is to propose that we can use machine learning to actually detect DDoS attack in a particular networking environment, especially in a software-defined networking environment. So this was my FYP1 plan to do my FYP2, basically to talk about the creation of my own SDN dataset using my own SDN simulation using Linux, and then talk about the hyperparameter tuning and the validation implementation for the XGBoost to get a better detection performance. And then I'm going to use a public dataset to actually train the XGBoost model so that it learns the patterns of a network from being a normal networking pattern and as well as the attack networking pattern. And then also to show the demo of the prototype that actually use the train model to detect the DDoS attack from the simulated SDN topology network that I've created to actually capture and record the custom dataset from TCP dump. So here we go. So right now, the first thing is the code snippets of this machine learning model. So the first code snippet is actually to import the required libraries. So this code, as you can see, the first code is to actually import the required libraries for the data processing, the model training, the evaluation, as well as the saving the trained XGBoost model for offline practical deployment later on. So this is the code snippet for that. So the second code snippet is to actually load the SDN dataset. So in this experiment, I've used the in SDN normal and attack combined dataset to actually train and test this XGBoost model. So this code loads the in SDN dataset and also checks the dataset structure, including the number of samples and the available features. So I load the SDN traffic dataset and as well as inspect its structure before performing pre-processing. Okay. So now the third code snippet is the label processing. So this code actually converts the traffic labels from the dataset into a binary format where normal traffic is represented as 0 and as well the attack traffic represent as 1. So the labels are actually converted into a format that the machine learning model can understand for classification later on. So now the feature selection, this code actually defines the final 10 final selected network features, which would be using the CIC flow meter later on. So these selected network features are used as the inputs for the XGBoost detection model. So basically, I select the most relevant network features uh, which will help to reduce the model complexity and as well as maintain the detection performance later on. So feature selection is very important because we're going to use the exact feature selections that will be converted from PCAP to CSV using CIC flow meter. Okay, that is a tool where it actually converts PCAP flow, network flow into a CSV dataset. Now for the data cleaning, so this is the code for actually used for data cleaning. So this code actually handles missing and invalid values to ensure the dataset is clean before training. So I clean the dataset by replacing the missing and also invalid values to prevent training errors. So now this is the train test split code snippet. So this code actually divides the dataset into a training and testing sets using an 80-20 ratio for the model development, sorry, and also for evaluation. So this dataset is split. so the model can actually learn from training dataset and as well as tested from an unseen traffic samples, which is the 20%. So now this is the hyperparameter optimization. So for this code trains the XGBoost classifier using a prepared dataset features to learn the patterns between normal and as well as attack traffic. So the XGBoost model is trained to identify the difference between normal and as well as normal network behavior and as well as data attack traffic by using this particular default sorry, not default, by using this optimized hyperparameter so that detection performance is strong enough to actually detect the patterns of the behaviors from the in SDN dataset. So now this is the model evaluation. So this particular code snippet is to evaluate the trained model using the testing dataset as well as generate the classification performance metrics. So the model performance is evaluated using accuracy, precision, recall, and as well as one score. And then last but not the least, this code snippet is actually to save the model. Actually, the code will save the train XGBoost model and select the featured list for future deployment and prediction, which is the offline deployment later on. So this train model is saved so it can be integrated into the offline deployment detection system without any retraining again. So this is basically this is the code snippets to actually build the default XGBoost machine learning model for the deployment of the offline DDoS detection later on.
Okay, so right now I'm going to actually create a SDN simulation network topology. So what are we going to do is right now we're going to create a box controller right now. So this is how to activate the box controller. So the first thing is we need to go inside the box home directory right here. So once we are in the box directory terminal, we need to activate the box command right here, which is this one. So right now the box controller is up. Now we're going to activate the mininet network topology. So this is how we activate the mininet topology. Go back and then so this one is the command where we're going to create one switch and 3 hosts with one box controller. So right now mininet has been activated and I'm just going to test ping all so that all the hosts are actually connected or all the hosts are actually communicating with each other. So as you can see, it is actually received. So now we're going to open extern for each node or each host so that we can actually create our topology capturing the network traffic flows. So right now we're going to So this command is actually to record the network traffic for all the hosts. So in this topology, H1, H2, and H3 will be recorded using TCP dump. So right now we are actually capturing all the hosts in the network topology. So we just need to open the extern for each host. So this is for node 1. So this is for host 2. And this is for host 3. So right now we have all the hosts that we need to actually create our normal and attack network flows. So the first thing is we need, how do we actually create our network? Normal network flow is just need to ping with each host with each other. So H1 is going to ping with H2. So as you can see, this is actually creating the ICMP network flow right here. So this is actually representing the normal network flow. So I'm going to do the same thing with node 2. So this will be communicating with node 3. So for node H3, this is going to be communicating with node 1. So as you can see, this hosts are actually creating the normal network traffic flow, and it's actually pinging with each host one by one. So right now the TCP dump is actually recording all of this network capturing, and this is how we actually create network traffic flow, whether it's normal or attack. So in this case, this is the normal traffic flow from the SDN simulation. So right now I'm going to demonstrate how are we going to create the attack flow. So let's take an example of H1 representing the attacker. So H1 is actually going to attack uh, node 2 or H2 here, host 2. So this is how it's actually going to attack. So we need to create this command, which is hping3 as flood. So it's going to actually directly attack H2. So this will actually create a burst of network traffic to H2. So we're going to press attack, and shortly it will actually create a lag, or it will actually disconnect. The communication will be disconnected because of the burst of network traffic flow to H2. And all of this SDN topology will actually have network simulation lag. So as you can see, it's actually stopping, and you can see destination host is actually working right here. And you can see for H3 node, it's actually creating, it's not, destination is not reachable because of the burst of traffic flow. And you can see this actually makes a lag right here. So this is actually, TCP dump is actually also recording this attack flow within the SDN topology as well. So as you can see, H2 is actually having a destination host unreachable problem. So this is how attackers attack this is a simple attack where it actually, attackers can actually give lagness to the SDN topology in a short period of time. So we're going to cancel this. And as you can see, this is the packet flow that has been created here. And it has, this is a short-term burst of network traffic, which actually, stops or lags the whole SDN topology because of the short-term burst of network traffic from the command, which actually creates a SYN attack. So right now we're going to exit the whole, we have already captured the normal traffic and as well as the attack traffic. So we're just going to exit. So as you can see, the SDN topology has stopped, and all the files the network captured is actually saved right here. H1, H2, and H3. So these are the individual files, individual PCAP file that we are going to convert it using CIC flow meter later on to actually upload it into our offline detection system using our XGBoost model machine.
So this is the file, this is the CIC flow meter UI right here. So this is where we're going to convert the PCAP file that we have captured from the SDN topology, and then we're going to turn it into a CSV file. So as you can see, we take one of the examples right here. So these are all the different time duration of the host network traffic flows. So as you can see, it has recorded 30 minutes of normal traffic flow, and then you have 30 minutes of normal plus attack traffic flow and all this. So we're going to take the 1 hour and we're going to convert all of this file into from PCAP file into a CSV file. Okay. So what we're going to do here is we're going to load offline right here, and then we're going to browse the directory. So we're going to choose this file, and then we're going to put it right here. Okay, so we're going to convert this. So right now the PCAP file is the CIC flow meter is actually converting the PCAP file into a CSV file. So right now the PCAP file has been converted into a CSV file. As you can see, the H1 node, you can check it out in this right here. So you go back to this file, and as you can see, the H1 from PCAP, it becomes a CSV file right here. So right after we convert the H1 or the PCAP file into a CSV file, which is this one right here. So right now we're going to open our offline DDoS detection system and analyze that particular network traffic. So we're going to use the H1 PCAP file to actually analyze the network traffic that we captured from the SDN simulation. So we can do that by opening our VS Code. Then we're going to use Streamlight to run the app. So we just need to wait for a minute. So this is the UI of the SDN DDoS detection system. This is actually based on the XGBoost machine learning model that we have trained before this. So right now, user can actually choose a CSV dataset file to actually analyze the network traffic that they have captured from the SDN simulation. So in this case, I'm going to choose the same H1, and that will be from dataset training. So this is the H1. This is one of the node host, which is H1 node. So I'm going to choose this, and it's going to give a result visualization. So it'll be loading for a while. So as you can see, this is how the XGBoost model detect the network flow of the particular node from the SDN simulation. So this is the result visualization, and as well as if you want to individually look at the network pattern from the particular host from the SDN topology, you can actually look at here. So this is all the 84 features that is provided from the CIC flow meter, because when we convert the PCAP file into a CSV file,
the CIC flow meter will actually convert all those into a flow numerical features based on flow features. So this is all the 84 features that is converted from CIC flow meter. And lastly, it will show a prediction where it will show which network flow is, which column or row is actually normal and which is attack flow. And to analyze even more, you can actually download the result right here. So basically, this is actually a prediction used by or learned using the train SG model to actually analyze and detect the DDoS attacks from the SDN topology or the SDN simulation that we have conducted just now.